Hope everybody is doing well. And let's go ahead and start it with our chapter 18, third part of your homework problems. Okay, so I think in the previous sections we did up to 14. Now let's look at number 15. A solution is prepared by adding 0.1 mole of sodium fluoride to 1 liter of water. Which statement about the solution is correct? Now, this section or the rest of the questions talked about mainly if you have a salt. Salt is when you add an acid and a base, you can make a salt. Remember acid-base reaction, you had learned this long time ago. If you have an acid and plus base and you are going to make water and salt, right? So this acid could be a strong acid or the weak acid, or the base could also be strong base or a weak base, right? If you take a strong acid, for example, let's say hydrochloric acid, and then the base, if it is strong, it's sodium hydroxide. So the salt that you are going to make is OH and hydrogen will make a water molecule, and then you're going to make sodium chloride, right? That sodium chloride is the salt. So when we are trying to figure out whether a salt that you are given going to be acid or base, what you have to look at is what are the acids and the bases that combine to make that salt. Now when you take sodium chloride came from strong base sodium hydroxide and strong acid hydrochloric acid, and you are going to make sodium chloride then water. Since the acid and the base both came from strong acid and strong base, the sodium chloride salt, when you put it into water, it's gonna completely dissociate into sodium ions and chloride ions. And this sodium ion and chloride ion, since it's just one way reaction, it's not going to go back, and it's not going to go back to make for example sodium ion with water. It's not going to go ahead and make sodium hydroxide. This is not going to happen because sodium cation came from a strong base. Similarly, chloride anion, when you put it into water, it's not going to make hydrochloric acid because it's a strong acid. Chloride is not going to react with water. Okay, so the sodium chloride salt would be neutral because it's not going to form acid or a base back again. Okay, so the solution would be therefore neutral. So likewise, when you are trying to find out whether salt is going to be acidic or basic, you have to take into consideration what are the anion and cation original sources of acids and bases. If it comes from a strong acid or a strong base, those ions are not going to react with water. Okay, so if it is coming from a weak acid or a weak base, then they are going to react with water. I talked about this in our lecture also, lecture videos. So with that in mind, let's go ahead and try to do these problems. Okay. Alright, so the first one is sodium fluoride. First thing, when you are given a reaction like that, see here you have sodium fluoride. You put 0.1 mole of sodium fluoride into 1 liter water. So sodium fluoride is again a salt. Sodium fluoride, when you put it into water, it's going to dissociate into ions, giving you sodium ions and fluoride ion. You put it into water. Now remember, sodium is a cation coming from a strong base, sodium hydroxide. You are not given that information here, but you have to, in your mind, you need to see that the sodium ion come from a strong base, sodium hydroxide, which is a cation from a strong base. So it is not going to react with water to give you sodium hydroxide. So that sodium ions are not going to react. Now you take fluoride ion. Fluoride ion is an anion. Now is fluoride ion is the anion of a strong acid? Remember, our strong acids are hydrochloric acid, sulfuric acid, and nitric acid, perchloric acid, and also we have our hydrohalic acids HBr and HI. So these are 1, 2, 3, 4, 5, 6. These are our strong acids. Does fluoride belong to any of these strong acids? No, right? So then the fluoride is coming from a weak acid. Okay, so if that is the case, it's going to react with water to form that weak acid. Right? So water plus fluoride. So fluoride, since it has a negative charge, it's going to react with a base. It's going to react as a base. So what's going to happen? Fluoride ion going to react with water. So this is your water molecule. Now if fluoride is the conjugate base of HF, your water going to be your acid. So the fluoride ion has lone pairs. It has 4 lone pairs. It's going to go and take this proton and then form hydroxide. It's going to form the weak acid HF and hydroxide ion. Okay, it's going to form hydroxide ions. Because it's a weak acid, it's easy to generate at least a little bit of weak acid. But it will never form strong acid or a strong base in this way. Right? But since it's a weak acid, it's going to form HF. And by doing that, it gives hydroxide ions to the solution. So as a result, sodium fluoride, when you put it into water, the solution will become basic. Okay, that's how you figure out whether you are going to get a neutral solution, acidic solution, or basic solution when you put your salt into water. Okay, so with that in mind, you can find out what is the most appropriate answer for this question. Okay, I gave you the answer. Just revisit and read the choices and find out what is the correct answer. Next one, similar. Now this solution is prepared by adding sodium sulfide and water. Which statement about the solution is correct? Again, the first thing you're going to do is once you are given this salt, you put it down and then write down what are the ions that it is going to form. Sodium sulfide is a salt. So when you put it into water, it's going to give you 2 ions, sodium ions. Since there are 2 sodiums, so 2 sodium ions, and sulfide. Sulfide is charge -2. Right? And then you're going to see, is sodium going to react with water? What do you guys think? Sodium is a cation from a strong base sodium hydroxide. Can sodium ion, positive ion, with water form sodium hydroxide? No. So cation of a strong base is not going to react with water. So then we're going to look at sulfide ion. Sulfide ion with water, what is it going to form? Now, it's going to take a hydrogen from water, right? HS -1 plus hydroxide, right? So it has S2 minus, meaning it's going to react as a base, and water would be your acid, and form hydrogen sulfide and OH minus. Is this one sulfide ion coming from a strong acid? No, it's H2SO4 is a strong acid, not HS minus. So sulfide is the anion of a weak acid, HS -1. So it's going to react with water to form HS -1 and hydroxide ion. So what kind of ion it releases to the reaction medium? A base, hydroxide. So what do you think the medium going to be? Acidic, basic, or neutral? You got the answer, right? So it's going to be again basic. Okay. So with that in mind, you should be able to complete the rest of the answers. Let's see number 17. Now this one, you are preparing iron nitrate solution. You put it into water. Now what happened with iron nitrate? FeNO3. Again, what you're going to do is you're going to break this into ions. So you're going to make iron 3 plus 3 nitrate ions. Okay. So remember the charge of the iron is +3, nitrate is -1. We learn about the crisscross pattern, how to find out the charges. So iron is 3 plus and there are 3 nitrates. Now the nitrate, an ion of a strong acid, hydrochloric acid. So the nitrate ions is not going to react with water. Nitrate with water, since it's going to form a strong acid, nitric acid, sorry, there won't be any charge there. Nitric acid, this reaction is not going to take place, because as soon as a nitric acid forms, it's going to go back to hydrogen ion and nitrate ion, right? So since it's an anion of a strong acid, it's not going to react. Now let's look at what's going to happen with the iron. Remember, in your lectures we talk about, like if you have aluminum 3 plus, or you have chromium 3 plus, or you have iron 3 plus, these can react with water to give you a hydrated complex, right? Plenty of water can give you FeH2O, 6 ions having 3 plus charge. And I showed you in a previous, I think it's the first question, where when you have 6 water molecules, what's going to happen? So the further this can react to give you one of the water molecules will, OH bond will become more polar, and as a result another water molecule can grab a hydrogen from the water molecule and make hydronium ion. Okay. I showed you this one earlier also, but let me remind you what's going to happen again so you will not forget. Over here. Come down. You see here? It's the same thing. Over here. Now what you have here is aluminum, but the same thing can happen with iron 3 plus or chromium 3 plus. So this is what I just have written in that slide. Fe, water, 6 water molecules with 3 plus. And then with one of the water molecules, these bonds, oxygen hydrogen bond, can be more polar because there is a electrons would be pulled towards your ion, Fe3 plus. So oxygen hydrogen bond get polar and then it become weaker, so another neighboring water molecule can grab that hydrogen and will make it OH group right here. So as a result, what's going to happen is you're going to be making hydronium ion. So what would be the resulting solution going to be? Since you are releasing a hydronium ion, is it going to be acidic, basic, or neutral? When you are releasing hydronium ions to the solution, that's going to be acidic, right? So that's how you're going to answer that question right there. Okay? So you can, it's not going to be strongly acidic. Okay? Okay, we are at number 17. Sorry, I was looking at number 18. So it's going to be, yeah, so you see the, I can see the answer right there for number 17. Now let's look at number 18. Ammonium chloride. It's asking whether the ammonium chloride solution going to be acidic, basic, or neutral. Let's do the same thing for ammonium chloride. First thing you're going to do is you take ammonium chloride, you break into its ions, it's going to form ammonium ions and chloride. And then you take chloride and then see if it's going to form any kind of acid. Now chloride, is the anion of a strong acid hydrochloric acid. If it's going to generate a strong acid hydrochloric acid, it's not going to react with water. Because as soon as hydrochloric acid is being formed, even if it is going to form, it's not going to stay like that. It's going to completely dissociate into ions. So, anions from the strong acids or cations from the strong bases, they are not going to react with water. So, this reaction will not happen. Formation of hydrochloric acid. So, we keep it aside and then you take your ammonium ion. Now the ammonium ion is the cation of a weak base, ammonia. So this can react with water, right? So then what's going to happen? Since it is the weak base, it's the base of ammonia acid, water going to react as base here. So water going to take a proton from ammonium cation and become hydronium ion and ammonia NH3. So we have ammonia and hydronium ion. So always you're going to look at whether it is going to release hydroxide or hydronium ion. If it releases hydronium ion, is the reaction as medium going to be acidic, basic or neutral? It's going to be acidic, right? Hydronium ion. So you can answer the question accordingly. And then the number 19. A solution is prepared by adding lithium nitrate to 1 liter of water. Let's see, lithium nitrate. What do you think about this? So you take the lithium nitrate. Lithium nitrate, again, you're going to break it into its ions. Lithium ion plus nitrate. Now lithium. Lithium is the cation, right? So with lithium, if you're trying to make it to work, what you would make is lithium hydroxide. What do you think about the lithium hydroxide? Is it a strong base? Yes, it is, right? So the bases, it's a Bronsted-Lowry base. Hydroxide in your group 1 hydroxide, your lithium, sodium, potassium, rubidium, those hydroxides. And then the group 2, strontium, calcium, barium, those bases, hydroxide with those metals are strong bases. So lithium hydroxide is a strong base. So lithium cation is not going to react with water to give you lithium hydroxide because lithium is a cation coming from a strong base. So the nitrate, you take nitrate. What about nitrate? Nitrate is an anion, right? And that anion from the strong acid nitric acid. So this reaction also not going to work because nitrate not going to react with water to give you nitric acid. Even if it does, it completely dissociates into ions. It's not going to exist, right? So as a result, lithium ions and the nitrate ions are not going to react water to give you any acid or base. So what does that mean? Is the solution going to be acidic, basic, neutral? What do you think? It's going to be neutral, right? The values Ka and Kb known. No, we don't need to know Ka or Kb because they both ions coming from strong acids and strong bases. If the ions are coming from weak acids and the weak bases, then we need to know the Ka and the Kb. Okay. 20. Aqueous solution is prepared by dissolving the salt formed by the neutralization of a weak acid and a weak base. Which statement about the solution is correct? Now we have a salt. It is made by a weak acid and a weak base combination. So we need to find out whether the solution is acidic, basic or neutral. So what's the correct answer? So we talk about this also in the lecture. The values of Ka and Kb for the species in solution must be known before a prediction can be made. Okay. So if you know the Ka and Kb, whichever become the higher value, whether it's going to be the weak acid or the weak base, that is the predominant reaction. Okay, if it is combined from weak acid and a weak base, we should know Ka or Kb in order to find out the acidity or the basicity of the reaction medium. Okay, so the correct answer for 20 is E. Which one of the following will give aqueous solution pH less than 7? Meaning now you have to look at all these combinations and see whether it's going to provide hydronium ions. Whichever produce hydronium ions, meaning that is acidic, pH is less than 7. Let's look at sodium acetate. So sodium acetate is first one. Okay, so CH3COONA. So we break this into ions. It will give you sodium ions and acetate ions. And then is sodium going to react with water? What do you think? Remember, I've been telling you all this time. Sodium is a cation from a strong base, sodium hydroxide, so it's not going to react with water. What about the acetate? Acetate ion is the conjugate base of acetic acid. React with water to give you acetic acid CH3COOH. If a one hydrogen lost from water, what would you end up with? A hydroxide ion. So this reaction, acetate ion reacting with water, releases hydroxide ions, meaning there would be a basic solution. So is the A correct? No. It's going to be pH greater than 7. What about ammonium bromide? So ammonium bromide, tell me what are the ions that's going to form ammonium bromide? What are the two ions? Ammonium ions plus bromide. Now bromide is the anion, right? Bromide with water. Is it going to react with water, bromide ions? Remember, the bromide is the anion of the strong acid hydrobromic acid. So if it is going to form a strong acid or a strong base, they are not going to react with water. Okay, so bromide will do nothing for the pH of the solution. What about the ammonium ions? What's ammonium going to do? Let's see. It's a cation of a weak acid. It's a cation of the weak base ammonia. So ammonium ion react with water to give you here, what is going to act as the base? So it's going to take a proton from ammonium ion and become hydronium ions and ammonia, NH3. What happened in this case? What has it added to the medium? Hydronium ion. So ammonium bromide solution is going to be acidic. If it is acidic, pH going to be less than 7. So there we have an answer. Okay, but let's look at the other ones too. Sodium carbonate. Try to do this yourself and try to understand what's happening here. So sodium carbonate going to give you 2 sodium ions plus a carbonate. Sodium ion, again, now you know, I've been telling it all the time. It's a cation from a strong base, sodium hydroxide, not going to react with water. And carbonate is the anion of the weak acid HCO3 minus. So carbonate can react with water because it's going to act as a weak base. Carbon will take a proton from water. Carbonate going to react as the weak base. Okay. To give you acid carbonate anion. Taking a proton, that's a Bronsted-Lowry base. Plus hydroxide ion. If a water molecule lose a proton, that would be OH minus. Okay, don't worry about bicarbonate and hydroxide both having negatively charges. That's perfectly fine because it has one carbonate here, CO3 2 minus, taking a one hydrogen will make it HCO3 minus. So this is going to be your base acid, and conjugate acid, conjugate base for the water. So what happened? Carbonate reacting with water, what kind of ions it released? It released hydroxide ion, meaning it's a basic solution. It's going to be pH greater than 7, right? Okay, so the next one, potassium iodide. What do you think about that? Can you do this and see what kind of ions it's going to release, and what is the solution going to be, acidic or basic or neutral? So it's going to give you K plus ions and iodide ions. Look at the cation. It's a cation from strong base potassium hydroxide. So it's not going to react with water. And iodide is coming from strong acid hydrogen iodide. So that also not going to react with water. If they both are not going to react with water, it's not going to be adding any hydronium ions or hydroxide ions. So as a result, Ki solution would be, what is it? Neutral, right? It's not acidic or basic. And then you have methyl hydroxide or methanol. Is it a base? It has a OH group. Can we consider it as a base? So remember, Bronsted-Lowry base is that you have a hydroxide group in it. No, Arrhenius base. Sorry, I got it confused. Arrhenius base is that it has a hydroxide group. Bronsted-Lowry base is something that can accept a proton. Can you consider methanol or methyl hydroxide as a base? No, right? Though it has a hydroxide, the group that prior to it is a methyl group. Remember, the base is categorized as when the hydroxide is combined with a group 1 or group 2 metals, like sodium. It has to be a metal, or lithium, potassium, like that. But methyl group, it's not a metal, right? So you cannot consider anything with that methanol. Okay, so we have an answer for number 21 too. Number 22, which, so all of the choices where if you are given a salt and to see whether it is going to be acidic or basic or neutral, this is how you're going to approach those problems. Okay, I hope you guys understood that. Now, the few questions are based on Lewis acids and Lewis bases. Remember, Lewis acid is something that are electron deficient, that it can take a pair of electrons having an unoccupied p orbital. Lewis base is something that it has a lone pair of electrons that it can donate to make a bond or form a bond. Okay, so with that in mind, which of the following is considered a Lewis acid? Okay, methylamine, CH3NH2. So here, nitrogen has a lone pair. If you remember how to draw the Lewis structure, there are 3 bonds on nitrogen, 2 hydrogens and the methyl group, plus it has a lone pair. So methylamine is in fact a Lewis base as well as a Bronsted-Lowry base. CH4 will not act as acid or base because it has a full octet on carbon. It's neither going to donate a lone pair of electrons or would not be accepting, right? But BCl3, if you know, if you remember how to draw the Lewis structure for BCl3, it would be like this. So boron has 6 shared electrons, right? So boron can accept a pair of electrons from somebody else. So Lewis acid definition is that you are capable of accepting a lone pair of electrons. So BCl3 can be considered as a Lewis acid. Now BF4 meaning boron with 4 fluorides. Now boron has 2, 4, 6, 8 electrons. So it cannot act as a Lewis acid because its octet is now complete. And fluoride, if you draw the Lewis structure for fluoride, it is like this. It has 4 lone pairs or 8 electrons. So what do you think fluoride is? Acid, Lewis acid or a Lewis base? It's a Lewis base. It can donate any of these lone pairs to make a bond. Okay, so the Lewis acid is BCl3. Now 23. Which of the following is a Lewis base? Lewis base is something that it has a lone pair of electrons that it can donate to form a bond. Now if you see like charges 2 plus, meaning it has lost electrons. Ammonium ion, again it's a positively charged, meaning it's a formal charge in fact on nitrogen. It also has a full octet. Nitrogen with 4 bonds to it, it has its full octet, so it doesn't have any lone pairs that it can donate to form any more bonds. BCl3 has 6 electrons. It's a Lewis acid in fact. It can, excuse me, remember we talk about it here, it's a Lewis acid. And then the chloride. What about the chloride? Has a negative charge, meaning if you draw chloride Lewis structure, it's like this. It has in fact 1, 2, 3, 4 lone pairs that it can donate to form a bond. Any one of these lone pairs. So it can act as a Lewis base, which is the chloride. And copper 2 plus. Again, 2 plus meaning that it has lost electrons. Meaning it can gain electrons but it cannot lose. Right? So this is again can be considered as a Lewis acid. So this is also Lewis acid. This can also be considered as ammonium ion. It's not a Lewis acid, it's a Bronsted acid. And manganese 2 plus also a Lewis acid. Okay. So now we found what is the Lewis base. The next one, 24. Which of the following will give an aqueous solution of pH closest to 7? Again, same concept that we did in the previous questions, where you have to see what kind of a solution it's going to make when you put it into water. Carbon dioxide. Carbon dioxide with water. Carbon dioxide can react with water to give you hydrogen carbonate and hydroxide ions. Okay, it releases hydroxide ions, so that's going to make a basic solution. So this is going to be your acid and this is your acid. This is going to be your base, carbon dioxide, right? Conjugate base and acid. That would be basic. And then what about the methylamine? Next one, which is ammonia derivative. Methylamine CH3NH2 plus water. Just like ammonia reacting with water, ammonia is a base. It would make CH3NH3 plus hydroxide. Again, it releases hydroxide ions, making a basic solution. Same thing with ammonia. You see, it's similar to ammonia. Here we have 3 hydrogen. In the previous methylamine, you have 2 hydrogens and a methyl group. Same way. It's going to give you ammonium ions, NH4 plus, and hydroxide ion, giving you a basic solution. What about potassium nitrate? We talk about a similar one before. Potassium nitrate, KNO3, give you potassium ions and nitrate ions, right? So this is a salt made from strong base potassium hydroxide, cation from a strong base, and anion from a strong acid. Are these going to react with water to any extent? No, because potassium hydroxide and potassium nitrate will not be formed again in water, because they are strong acids and strong bases. So since they are not going to react with water, their solution going to be neither acidic nor basic, meaning it's neutral. Neutral is closer to pH 7. Now let's look at the last one, ammonium iodide. Ammonium iodide, break them into ions, ammonium ions plus iodide. Can iodide react with water? It's going to generate a strong acid Hi. So it's not going to react with water. It's an ion of a strong acid. What about the ammonium ion? We have seen it now several times. Ammonium ions with water going to give you ammonia NH3 and a hydronium ion, adding acid to the water, making the solution acidic. We want to find out which one is closer to 7. Now we have the answer. I just showed you it, right? It's potassium nitrate. And number 25, which one of the following is a Lewis acid but not a Bronsted-Lowry acid? Now the Bronsted-Lowry acid means it's something that you can donate a proton, Bronsted-Lowry acid. Lewis acid is something that you can accept a pair of electrons. Okay, now let's look at ammonia. What is ammonia? It's a acid or a base. We are looking at Lewis acid but not Bronsted-Lowry acid. So ammonia is it can either considered Lewis base since it has a lone pair, or a Bronsted-Lowry base. So this is a base. What about water? Water can act as acid or base. So we're going to keep it like that. Iron 3 plus. Lewis acid. Iron 3 plus. Remember we had seen with water iron can grab 6 water molecules. So iron 3 plus, anything that is electron deficient like the positive charge can be considered as a Lewis acid. Hydronium ion. What is hydronium ion? Hydronium ion is a Bronsted-Lowry acid because it can donate a proton. What about hydrogen sulfate? It's not a Lewis acid, it's a Bronsted-Lowry acid because hydrogen can be lost to give you a sulfate ion, right? So it is acid, but it's a Bronsted-Lowry acid, but not a Lewis acid. So the Lewis acid is Fe3 plus. Okay. So that concludes our questions for chapter 18. Okay then. Bye-bye for now.